Okay, this morning I have the great pleasure of introducing you to Bert I'm going to mess this up, Schiettecatte, who is the main person behind Percussa, the company that does the Percussa AudioCubes. Now, I got introduced to these, first of all, by Bert himself at a NAMM show at one point where he was showing some early versions of this. We had talked about Max MSP programming back then. I was reintroduced to them by my friend Mark Mosher, who has become a bit of a savant with AudioCubes and has worked it into his performance practice in a very deep way. So I seem to just keep on running into AudioCubes everywhere I turn, and I was really excited to get a chance to talk to Bert. So good morning, Bert. How are you?
I'm good. How are you, Dorian?
I'm okay. So you're in Belgium, so actually it's not morning for you. It's sometime in the afternoon, right?
Yeah, it's 5:30 p.m. here.
Oh, all right. Well, so good afternoon to you. So I gave a brief introduction there, a little bit about what you do. Why don't you fill in the blanks? Explain a little bit maybe what the AudioCubes are for people that aren't aware. And also maybe talk about what kind of development you do with them.
Okay, so the AudioCubes are basically an instrument, a combination of hardware and software, where the hardware consists of a network of smart wireless devices. In our case, it's a network of cubes. And each cube is basically a self-contained little computer that we designed that senses other cubes nearby, including their distance, orientation, as well as distance to other objects like your hand and so on. You could trigger sounds with those cubes, or you could control effects by moving your hands closer and further away from the cubes. Since the cubes also detect each other and detect each other's distance, you can also move cubes closer and further away from each other, and you can link that information to effect parameters or instrument parameters, like every cube could be linked to a module, like a software module that exists in your computer that is maybe an oscillator or a filter or something else. So in a sense, you could think of the cubes as like a wireless audiovisual modeler synthesizer in a way, where the sound generation part runs on your computer.
So a couple of things to make clear. The AudioCubes themselves don't make audio. They're really controllers for the computer-based system, right?
That's correct. Although the AudioCubes do signal processing, but they don't process audio or don't generate audio.
I see.
They generate optical signals and they interpret optical signals, which are sent between all the cubes.
Got it. Understood. The other thing is, how do they communicate between themselves and the computer?
So it used to be that when we released the AudioCubes, all of that happened through the infrared communication network that the AudioCubes use between each other. We were using the infrared communication ports that each AudioCube has, and each AudioCube has 4 of these inputs and outputs. We were using those to sense the environment and to sense other cubes, but we're using those at the same time for transmitting data.
Okay.
So the cubes were forming a network using those communication ports, and they were like forwarding packets between the cubes, and so there was like a packet routing thing that we developed, and that basically made the data end up with the cube that was connected through USB to your computer. So the data would like hop over the cubes to your computer essentially. That worked fine in the beginning, but then we realized that the limitations of that, and that we wanted to make it way better. And that's when I started working on a wireless upgrade for the cubes, which is a little module that goes into each cube and that basically creates a star network. So then you have a direct communication path from every wireless cube to the central cube, which is connected to your computer through USB and which collects all the data.
Okay, so one of the cubes is sort of like the master, and that's USB connected, and everything else roams free wireless, right?
Exactly.
Got it. Interesting. That sounds like some pretty amazing technology. Did you develop all these network topologies and stuff yourself?
Yeah, I had to, because when we looked at various wireless options for the cubes, we looked at Wi-Fi, but Wi-Fi was really power hungry, and we didn't want this experience like you have with a router that you buy, where you have to figure out how to set it up and how to, make all the devices get an IP address and all that kind of stuff.
Right.
And so I didn't like Wi-Fi too much because of that. And then I looked at Bluetooth, and then Bluetooth seemed to be this thing that was developed by people in a meeting room who had no idea about the music industry or what people in the music industry really wanted or what was important to them. So it was like this thing that was developed for sending pictures of your pets,
right?
Your iPhone to somebody else's iPhone or whatever. And then later on, of course, now with Bluetooth, with the new Bluetooth standards, they're trying to sort of get away from that. And they also kind of try to do new things with it, but I think they're like super late with that. So when I looked at it, Bluetooth was like in its very early stages, and it was just not what we wanted. And also, Bluetooth was limited to like 5 or 6 slave devices.
Yeah, I was going to say, I didn't think that you could come up with near the topology that a complex AudioCube system would require.
No, I wanted to be able to have a 1.15 network, so one central cube and 15 wireless cubes.
Right.
And I wanted it to work in real time and with relatively low latency. And I wanted to be sort of like, if something would drop off, it wouldn't be a disaster and it wouldn't cause any other problems in the network. So basically we had all these ideas and these requirements that were just not possible to satisfy with something off the shelf like Bluetooth.
Sure, that makes sense. So Bert, I've got to ask a question. One of the things I like doing in my podcast is I like talking to people about how they became the artist or technologist that they've become. In your case, it seems like there's some kind of real interesting map there because, it's clear that you're not only a musician, but you care very deeply about instrument design, but you also have strong enough engineering chops to be able to develop kind of your own network stack. What is your background? How did you get to the point of being able to do all those things simultaneously? And how do you maintain a high level of knowledge in all of those areas? I know that's like a million questions, but I'm just really curious about how you got to be who you are.
So maybe I'll go back in time a bit and explain a bit about how I ended up in music technology, and then feel free to pull me off on a tangent when you think it gets interesting.
Okay.
So when I grew up, I went to music school. Like we have classical music education here in Belgium. It was like the only thing I could get into was classical music education. It was the only thing we had in school, and there was no jazz school or anything close by. I just did that. Went to classical music education. It was a horrible experience because in Belgium, at least at that time, you take classical music education and they make you take theory for 2 years, and then you can pick an instrument. You can go play the instrument, but basically that involves practicing scores in front of a piano one hand at a time, like 15 minutes a week, something like that.
Right.
And so it was not a very enjoyable experience. And, my parents put me there because it was like the only thing that they could imagine that I could do in music was like, let's put him in music school or something like that.
Right.
Which is understandable. But today, if I had kids, I would take a different direction. I would put them in jazz school or something like that. But
sure,
we didn't have that at that time. So anyway, so I was in high school. I was doing that. I was kind of fed up with it, and then I had an interest in electronic music because of classmates listening to electronic music, and I had discovered Biosphere. I don't know if you know that artist.
Yep.
So I was into ambient music and electronic music, and I had heard some music of Jean-Michel Jarre and all that, and
right.
And all the other kids in class were playing guitar and all that, and I didn't want to be like them. So so I asked around, and I ended up I realized I needed synthesizers and samplers and mixers and that sort of thing.
Right.
So and that obviously cost a lot of money because that was like at the time when a basic sampler would cost like $2,000 or something, right. And it had 2 megabytes of memory or whatever. So the only way for me to get that sort of money was to get a job somewhere. I just turned 15, and that's when that's like the age when you can get a job.
Okay.
Like during the holidays or whatever. So I was in a demo group. I don't know if you know about the demo scene. Like demo scene was like a big thing in Europe.
The computer programming demo scene.
Yeah, like the people who were in like these demo demo scene groups where they would like program little demos and go to competitions and that sort of thing.
Sure.
And I didn't know very much about programming yet, but there was a guy there who knew somebody who had a company and who was looking for a web programmer to do like HTML coding and some Perl stuff and all that.
Okay.
And I had some really basic HTML skills, and I had put up a website for the demo scene group, and that's how I got my first job as a kid. And then from there I learned Perl programming. And I worked in this company, saved up money, and then I started buying samplers and synthesizers and and a mixer and speakers. And of course, that took several years because if you add all that up, I mean, today that doesn't cost a lot of money anymore. But
right,
like then it was
to be crazy.
$10,000 or something like that. And of course, if you're in high school, you don't have $10,000.
Right.
But I did that, and then I made a record with a friend. And I was thinking about where I would take my career because I was getting close to graduation, and I had to figure out what to do.
Okay.
Then I realized, well, I'm actually really interested in music technology, and if I'm going to be, and I was also doing a lot of stuff with computers in general. I was like playing adventure games besides making music, all this kind of stuff. I was like a big fan of the LucasArts and Sierra games.
Right.
And so I really wanted to go do something with computers, but I was not all that interested in like, normal, IT stuff or stuff like that. I didn't want to be like a server administrator or something like that. So the only thing for me to do was to go to computer science. And I realized, okay, if I go into computer science, I can also do stuff with music technology. Because then obviously I will learn how to program better, and I will be able to do stuff in music technology.
Sure.
And I wanted to build synthesizers and drum machines and that sort of thing. I was really like blown away by those instruments at that time. I had a Korg wave station, which was, I think, the moment when I said, this is what I want to do. So this was like the main synthesizer for me that made, So like the Korg wave station was like an example of this is a great thing, this is what I want to build. And then I had an Akai sampler, and this was like, okay, this is not how to build it. Even though the machine sounded great, the way to interact with it or use it was for me really frustrating. But that's
Sure.
like because of the interface, of course. But
Right.
So anyway, so I went to university for computer science. I went to Brussels University, which has a really good computer science program. And there, every year we had to take a yearly mandatory programming like project, which is like the major part of your grades.
Right.
And so it's a mandatory thing. But again, I wanted to do stuff with music, so every year I would build like some music software somehow. By the time I got to the third year, so it's a 4-year program, which ends in a master's. And in the third year, you're supposed to do like an internship.
Okay.
And so I had built this open source editor for MPEG-4, Structured Audio Orchestra Language,
Right.
which was like a standard that was being developed at MIT. So there was a command line compiler for it, and the idea was that you could describe an instrument and then compile it and then put it in the MPEG-4 bit stream.
Okay.
So it was like C sound, but it would go into an MPEG file essentially. But there was no editor for it. So I built an editor for it, like a graphical editor, sort of a Maximus P, but very, very simple. Because of course we only had like 1 year. We couldn't work on it like 5 years or whatever.
Right.
Or even longer. So I built something very simple and I put it online. And then I got in touch with some people in the US who had a company and were looking for interns. But I was looking for an internship. So I went over there and I interned with them for a couple of months. And they turned out to be people from Stanford Center for Computer Research in Music and Acoustics.
Oh, the Karma Group. Yeah.
Yeah. So that's how I met some of those people. And then I decided when I came back that I really wanted to study there. And I was really blown away by SynthBuilder, which was like a tool that they had developed at Stanford back then. Mm-hmm. Which was also kind of like a Maximus P, but different in that it used a Motorola 56K series of DSP.
Right, yeah.
So I came back, and through a pure coincidence, my parents met somebody at the airport who was like a director of a grant organization in Belgium, and who told them like, well, if you want to go to Stanford, it costs a lot of money, but we have a grant organization. You can actually apply for a grant.
Interesting.
Which and I didn't know anything about our organization.
Right.
I looked it up and I applied, and it was a year of hard work to put together, like the case, because all these things you need to do to apply to like Stanford or MIT or whatever. It takes like a lot of work.
Right.
So I worked on that for a year, and I got the grant, and I got into Stanford, which was like a major thing for me. And so I went over there, and I took their 1-year Masters of Arts in Music, Science, and Technology program, and that's when I started building hardware. That's like when I really got into hardware, because Max Matthews and Bill Verplank had an amazing interaction design class for music.
Okay.
And there was a really great small lab there with oscilloscope and soldering irons and that sort of thing. Like for me, that was like the most interesting course there. It was like the thing that really blew my mind, I think. And because now I could also do hardware. I was not only doing software then, I was also doing hardware.
Right. And yeah, I was curious about how you would make that transition, because a lot of people that start off in software find it really difficult to embrace hardware. But you seem to have made the transition. But I can see that spending time at Stanford would certainly have made that somewhat easier.
Yes, it did. And the good thing about the class was like it was being taken by all sorts of different people from all over Stanford. So there were like mechanical engineers in that class. There were like music students in that class. Really, really diverse kind of students.
Right.
Which is really great, because if you want to put together a small team of a few people to do something, then you can have a computer science guy, you can have a mechanical engineer, you can have a musician, you can have like all the necessary components to do something like that.
Right, all the people are just in the same class with you, right?
Yeah, so that was like, I think, really like a crucial thing for me to get into hardware. And so I joined up with Ito Otetigbe, who was an MIT student who was at Stanford, was doing the mechanical engineering program at the product realization lab at Stanford.
Okay.
And then there was somebody else in the class, Luigi Castelli, who came from Berkeley and who had actually studied with Richard Boulanger, and who was like more of a musician type of person who also knew a lot about DSP.
Right.
So we teamed up and we built this laser harp. So we wanted to build like a laser harp like Jean-Michel Jarre has, but of course much smaller and with more sensors, and easier to transport and that sort of thing. And so we built that, and we rebuilt it a few times, I think maybe 4 or 5 times during that program. So even though the class was already finished, because the class was only like 3 months.
Okay.
Then next quarter or whatever, you have other classes, right? We just kept going with it, and we just kept working on that all year around. And Karma was great in the sense that it would encourage that. Like it would not mind if you kept working on this one thing all year round.
Right.
So I think that was like a very important thing. And then afterwards, of course, it was only a 1-year program. Then we graduated. And, they wanted to do some other stuff. And, my program was over, and my visa as well, because it was only like a 1-year thing. You only get a visa for 1 year. Okay. So I had gotten an offer for a PhD to go back to Belgium and to essentially continue the work that I was working on. But then when I got to Belgium, I realized that they didn't have the infrastructure. Didn't have the lab over there, didn't have the money and the resources to keep doing that.
Right.
So they were, so it was like a situation where I had to go do other things for the lab, or I had to figure out how to keep doing what I was doing. So after a while, I decided to quit the PhD program and start Percussa, and that's how the company was started, because I wanted to keep working on what I was doing, essentially.
I am really curious about something. So it seems like, right now, this idea of going to university and having a lab that has drill presses and soldering irons and oscilloscopes is kind of common. But at the time that you were going through school, it was just on the edge. You were starting to see like leading edge programs like Karma do that, but generally speaking, that wasn't the case. Now it's much more the case. Do you feel like access to that is important for a new generation that's trying to learn this stuff? Or do you think that they might be making it too easy?
I think it's really good that there is more of these tools available for people to do stuff. But then on the other hand, you also have to have the right mindset or the right attitude towards it. So it's not like, as a university, I think it's not a matter of like buying those tools.
Right.
It's also a matter of making them available in a way that like you don't have to ask for permission almost.
That's a really great point, and maybe is a little closer to home than the way I phrased it. It does seem like one of the really important parts of your experience with Karma was the fact that you were sharing this class with a bunch of other people, first of all, from different walks of life. So it wasn't just a whole bunch of people who decided they wanted to use soldering irons, or maybe that was just part of how they wanted to do their thing. But the other thing that's really key there is that even after the class was done, you had free reign to go into that lab. That seems to me to be the real powerful part of this.
Yes, because sometimes you have schools and they decide to invest in infrastructure, but then the infrastructure is not available to the students the way it should be.
Right.
And you have to do this or do that, or like, can only use it in that way or this way or whatever, or there's like departmental things, that are going on or whatever. And I think if you have a university where it's really free and accessible and nobody's really keeping you from doing something, I think that's like a really important thing.
Sure. Now I want to go back a little bit, again, talking a little bit about your education. Going way back to when you said that you were studying classical music and sort of the frustration then. I too grew up at a time when the only sort of like educational background for music was related to classical music. I felt like there were things that I learned from that were important, and a lot of things that just bored me, right? For you, were there things that you learned from that process that you still use or still depend on today?
Well, I think there are good things that I did pick up going through classical music education. I had with the first piano teacher I had, that was like the normal piano teacher that you get through school. But then afterwards I switched to a private teacher.
Uh-huh.
Because the time I could spend with a teacher in school was like 15 minutes a week or something, which was not going to get me much further.
Right.
So I had this old lady who would be like really push her students to get to like develop technique on a piano.
Okay.
And so that's something that I think I benefited from, to have technique. And then of course also being able to side read and that sort of thing.
Oh, sure.
But then on the other hand, I don't really use those skills, because I don't really actively play music that way or anything like that. You know what I mean? So it's good to have those skills, but I don't really use those.
Yeah. Are you actively performing now?
No, not at all. Because I really wanted to take some distance from playing the piano, because I almost wanted to forget that part, to be able to come back to the piano and to be able to approach it like a beginning jazz musician would do it or something.
Sure.
Not having this bad taste in my mouth anymore.
Right. So do you see you giving yourself time to do that? Because it seems like just the process of running a company that's developing hardware with this huge software backbone seems like that would keep you pretty busy, and it would be a little tough to take on a reintroduction into the piano. Is that something you think you'll be able to do?
It's definitely something I don't have time for right now because I have so much going on with development for AudioCubes that I just don't get around to it, to really playing an instrument again that way. I mean, no, I just don't get around to it, to be honest. I mean,
Sure.
I would love to at some point, but right now I just have too much going on to do that. So.
Right. So let's talk about your AudioCube development, because my understanding is that you have really been burning the midnight oil on a new release. Can you explain a little bit about what you've got in the pipeline?
Of course, yeah. So, so like I explained, when the cubes were originally launched, they didn't have the wireless module, which allows them to form this star network. And so, when I designed the module, then I then started working with a friend on the firmware implementation for the protocol that we wanted to use. But then, of course, I mean, the first version of that firmware and the protocol, it worked, but it didn't work the way I wanted it to work. Like, for example, it would not give you all the data simultaneously. So it was like either detecting cubes or it was sensing the environment, but it would not sense distance to other cubes, and it would not detect the other cubes while simultaneously giving you distance information to other cubes.
Okay.
So that, I mean, it had all these limitations, and I wanted to have all that data available simultaneously. So essentially, and also I wanted it to work much faster. I really wanted to have a really high update rate. So I decided to basically rewrite all the firmware and rewrite the library and rewrite the MIDI bridge, which is like the main application that you use to connect AudioCubes to other music software. And so that was a really big thing because I had to figure out how to build a protocol that would work for this star network, and where every cube would be able to sense its environment and then submit its information, and then all the information from all the cubes would have to be merged to form like the state of the network, essentially.
Sure.
With all the sensor data, all the distance, all the detection information and all that. So that was a pretty tricky thing to do. And also because it has to work in real time, and when a cube goes away and it comes back, you have to handle all those cases. Like, what do you do if you disconnect the whole network and you're on stage, but then you plug it back in?
Right.
Does everything come back automatically? And what do you do if somebody walks off the stage with a cube and it's out of range and then comes back into range? Or you turn it off and turn it back on? Or what if a battery dies and you have to swap two cubes?
Right.
The one that is plugged in, you unplug it, and then you plug the one with the dead battery back in so it can charge from the computer, but then all the other ones have to like join the new cube, which is like the new master cube.
Right.
So you have these endless things that you have to think about, and it all has to work in real time, and it has to work fast enough because musicians are really demanding, as you know.
Yeah, indeed. Well, I'll tell you, as you start laying out some of the complexity of the system, I find it remarkable then when I see, like my friend Mark, using these things in real time, and I see him swapping things out and plugging things in on the fly. And so I realize that all of those kind of failover systems and all that stuff are in use constantly. It's not like these are necessarily special exceptions. Just because working on stage with any piece of equipment, but especially a wireless piece of equipment, is just craziness all the time.
You would think it's exactly like you say. You think, okay, I don't need all those special situations, or they don't arrive or whatever. But I mean, if you're a live performer, guaranteed, those situations will come up.
Oh yeah, absolutely.
And something will happen, and you will have to, like, your system has to be able to deal with it.
Right. You have done all of this rewriting, and you basically you went from sort of cubes being what they are to being wireless to now being much faster and having more data sensing. Do the cubes require hardware updates in order to take on this new development?
Yeah, so the cubes, there is a tool that we provide that allows you to upgrade the firmware of the cubes. And
Okay.
it's very easy. I mean, you basically just push the on off button of the cube and you hold it for a couple of seconds, and then the cube turns blue. And that's like the sign you can plug it in to upgrade the firmware. And then there is a little tool, and you start it, and you drag and drop a file, and then it just flashes for a couple of seconds, and that's it.
But you don't have to change out any of the hardware at all?
No, you don't have to change the hardware. Although, if you bought your cubes, like let's say in 2007 or 8, then you do need the hardware upgrade. Like you do need this module. But you can actually get the module from us, and you can install it yourself if you have some basic like technical skills.
Right. Well, I think it's pretty amazing that you have a piece of hardware that was available in 2008 that still operates and is getting faster, because of your software development, is getting faster here in 2015. Do you mind telling us what kind of hardware is inside of that thing? It must be something you really are in love with.
Yeah, it's I designed the motherboard of the cube and the original motherboard, and I'd also designed the wireless module for it.
Okay.
And so at the time when I designed the motherboard, I didn't even know that we would have a wireless module, but I put an expansion port on the motherboard, which allowed me then later on to develop a wireless add-on that plugs into the expansion port, essentially.
Interesting.
So the main motherboard of the cube uses an ARM processor. So what the cube actually does is it does signal processing. It does signal processing, but like I said, not of audio signals, but it generates optical signals. It processes optical signals. It does all that. And then there is a coprocessor which handles all the protocol stuff. There's another processor that is responsible for taking data from the other processor and packaging it and decoding it and encoding it and all that sort of stuff.
Sure.
And registering with the network and all that. So that's kind of how the cubes work. But it's still the same motherboard from that we initially released, but now there is the wireless upgrade. And today, if you buy an AudioCube system, it comes with the wireless module installed, of course.
Of course, sure. Now, I want to go back to when you were first designing the first set of AudioCubes. I'm a little blown away just going through the process in my head. Because first of all, the AudioCubes use this kind of semi-transparent, very texturally enjoyable to feel kind of rubbery, plasticky stuff. I don't know what material that actually is. But then you built in colored lighting that could be controlled by this microprocessor and was bright enough to shine through the cube material. You developed a motherboard and with a coprocessor on it, you developed all these communication protocols. How long did it take you to develop this damn thing? Because it seems like you've had to figure out just about every manufacturing process that there is in order to produce these things.
Yeah, so when I started working on it in 2004, I had some really basic prototypes, and I think it took me until 2007 to get the first version of the AudioCubes done. And at that point, there was very little software, and the software was actually really crappy. It was very, very rudimentary. It was like I had sort of underestimated the amount of work it would be.
Right.
When I got into it, and I wanted to do USB, for example, on the AudioCube, and doing USB on a new device, like when you're not all too familiar with the processor yet, and you're still learning your way around the processor that you're using, but then you also have to implement USB.
Right.
It's a major thing because the USB standard is an enormously complex thing.
Okay.
And it's also implemented and handled differently on different platforms. So even though the standard says, when this happens, then you have to do this or whatever, but then when you go buy tools and you an analyzer, like a USB analyzer or whatever, and you put it on your computer and you put a device over it, then you realize that the operating system is not actually doing what's written in the standard.
Right.
So there is this thing, again, it's sort of like with Bluetooth, that the consortium of people who work on USB, they write this standard and they build this thing, but it's like super complicated for a small company to build a USB device. So I got into that, but so the majority of my time was like over those 3 years was like spent on that. It was like a really big thing. So I got the cubes to the market, and then of course after that, I realized, okay, we need better software. We have to build cross-platform software. How do we do that?
Mm-hmm.
And then how do we? And then from there, okay, what other things do we need? And it started with MIDI Bridge, which was like an application that you use to connect the cubes network to other software or hardware. So it turns the data from the cubes into MIDI data, which you can send wherever you want.
Okay.
Then we realized, okay, we have to build our own applications, because the problem is that if we only send data over MIDI to other applications, like let's say Ableton Live or so, then when that software was developed, there were no cubes,
Right.
actually, or the cubes were not. I mean, nobody knew about the cubes really yet. So
Right, so it couldn't take maximum advantage of them.
Exactly. So you have all these possibilities that the AudioCubes can offer, but then the software can only use a part of it because it's not designed for that.
Right.
And so that's what we realized, I think, around 2008. And that's when we said, okay, we start working on our own applications and our own instruments to take advantage of the cubes as much as possible.
Sure.
And of course, meanwhile, I started rewriting, the whole wireless thing. I mean, that took quite a while. And then we released updates for the wireless, of course, free of charge for all the people who wanted to use it. And so we started building some of our own applications. I think in 2009, we created this generative sequencing application called Improviser, which started as a Maximus P patch.
Okay.
And so it's basically an application where every cube runs a loop. And when you put two cubes together, the notes add up and they subtract.
Oh, okay, sure.
So every cube has its own loop, but the loop is relative to a root note.
Got it.
So the way you get the note that is being played is by, let's say, taking one step from one cube, which is +3, and then another one from another cube -2, and then you add that up with the root note, and then you end up with the note that's going to be played. So it's kind of a generative sequencing system where you use the cubes to play music in real time, and you put in the pitches and you put in the velocities, and then the music that comes out is sort of automatically generated because of the position of the cubes. So I started to develop these kind of ideas, like application ideas, and some of them, like Improviser, were interesting, other were not so interesting, like Evolver, which was more like an LFO kind of thing.
Okay.
But it was like all of those ideas were sort of like the breeding ground for the synthesizer that we're now working on, which is called Synthor, and which will be built into MIDI Bridge essentially. We're extending MIDI Bridge with audio and DSP possibilities, so you don't need anything else anymore.
Got it.
You buy the AudioCubes and it comes with a free synthesizer, and it's essentially a digital modeler synthesizer.
Right. Well, that makes a lot of sense too, because then you can demo it or you can tell people how to test and use the system without having to know what equipment or what software they're currently using.
Exactly, yeah. Then it's much easier. Like if you have a computer and it makes sound or has a sound card, you can connect the cubes to it and you can make music and sounds with it.
It seems like there's a ton of different applications that the cubes could work well for. I mean, some of them are, I think, what you're focused on, which is working with performing musicians who want a different interface with their music, and similarly with studio development and stuff like that. But there's also things like audio installation, art type work, or even, and probably most interesting, might be the education market. To what extent have you seen AudioCubes being used in those kind of environments?
So there are a couple of artists in Europe that I know of. Kim Peterson from DreamHub, who has built installations using the cubes. I think he did an installation in a church. I can't remember the name of the project, but it was like a big AudioCubes installation in a quite well-known church in Denmark, I think. And then he also played at the climate conference with the cubes. And then education. There are some schools in Colorado where they're using the cubes with small kids. So the music teacher uses the cubes with small kids, and he uses Ableton Live. And the kids, can trigger loops and play with effects and apply effects to their voice while holding a cube and waving their hands around the cubes and that sort of thing. So it is definitely used in STEM education. Where there is a music teacher who wants to show what you can do with technology in music. And the cubes are a very inviting, sort of non-threatening piece of technology. It's a group of wireless objects that lights up. Right. They're almost like lamps. So it's not like it's a computer that is intimidating. You're using a computer, but you're not necessarily, intimidated by it. It's not like computers can sometimes be associated with men or like with like, because of the male dominance in computers and in IT, computer science and that. And so the cubes are like a neutral thing.
Yeah, they don't have a predefined gender bias.
And so I think that's also where it is great in STEM.
Yeah, the STEM thing is actually really interesting. And I know that there are plenty of people that are trying to turn STEM into STEAM by adding arts into it. But regardless of whether they're successful or not, it strikes me that there are an awful lot of ways to get interplay between engineering type thinking and musical artistic type thinking. And so it seems to me like the cubes are really potentially great because they're inviting and because they're technology, but also because since they don't look like any other instrument you've ever used, you're sort of free to imagine something brand new and then try and make it.
Yes, that's very true. So like it's like what the cubes have. I mean, it's difficult because it's like an abstract thing, but then because it's an abstract thing, it doesn't necessarily push you to think about it in a certain way.
Right. Yeah, it's like, I mean, the sort of like the opposite equivalent of that. I've seen a lot of people do kind of interesting artistic tools using the old rock band guitar controller. But everyone I've ever seen use it makes something that sounds and plays and acts like a guitar. There's got to be something else you could do with that other than make guitar licks, So I think that's one of the real advantages of the cube. So in your experience and in working with users, what's the most complicated cube system that anyone's put together?
I think like one of the it's actually, I think Mark Mosher was recently working on a patch featuring the new topology stuff, which uses Yuhi's ACE synthesizer. I don't think it's out yet, so I can't say too much about it. That's like up to Mark to decide when he wants to show that to the world. But I think that was like, I was really blown away by that, by the kind of mappings.
Yeah, I think he shared that video with me. That's the one where he maps the cable connections of UE ACE so that you're literally changing the wired connections using the AudioCube. Is that the one you're thinking of?
Yes, and I was really like I was really impressed by that because it's the topology thing takes some time to understand what it actually is.
Uh-huh.
Even though it's a relatively simple concept, like, you have detection information between the cubes and you have distance information between the cubes. So essentially, you get all this network information that you can use to link things together, which exist in your computer. So when you put two cubes together, two things in your computer will be connected together.
Right.
So it's a relatively simple idea, but to get your head around it and to map it, let's say using Yuhi ACE is definitely like impressed and blown away by that, like the way Mark did that.
Well, he actually got you and I together for this podcast. He's long been a big fan of the AudioCubes, and he showed me that. And yeah, the topology thing, it makes sense, but coming to the point where you feel comfortable making those kind of mappings and then performing with them, I have to give Mark credit for having taken sort of like that leap of faith to be able to do that.
Yeah, I think at first he had to spend some time with it to understand how it worked. But then the moment he got the hang of it, he realized the power of it and the possibilities of it, and he went off and created this amazing mapping. So I mean, the reason we're building the synth that I mentioned is such that people don't have to do those mappings. So
Right.
we get, those mappings are automatically done for you when you use our synthesizer. You don't have to think about, I need to send these kind of MIDI messages and I have to map it like this or that. I mean, if you want that, you can do that, and you can build Maximus P patches and, and hook them up to the cubes and do whatever you want. But if you don't want to do that or you don't have the time for that, then you can use our synthesizer.
Yeah, well, and even even beyond that, so you may have in your mind that you want to use Max or whatever to create the ultimate thing, but sometimes when you buy something, you spend the money on it, you kind of want to have fun with it right now,
Exactly.
And
Yeah.
it seems like this built-in synthesizer gives you the opportunity to say, all right, 5 minutes into this process, you can at least have some fun. So that's great too. Okay, so given the time frame that you gave us just a few minutes ago, you have been working on the cubes in one fashion or another for a decade now, right?
Yes, yeah, that's correct. Yeah.
Do you ever get sick of the cubes?
I think, yeah. I think anybody who works on a project like that long, sometimes just wants to, drop it for a couple of weeks and go do something else.
Right.
So I also have some of these moments, just like everybody, but then people are also really excited, and when they use the cubes, and people email all the time, and then that's when you see, okay, there are people out there using this and they're having a great time, and that's in the end also why you do it, why I'm doing this.
That ends up being great motivation, right?
Yeah, people love it, so you keep doing it essentially. So
right. Do you have any plans to do another kind of hardware or maybe expand your software work? I mean, this synthesizer certainly sounds like an extensive project. Do you have anything else that you're thinking of taking on at any point?
Yeah, I have some ideas about other stuff, but I think will mostly circulate around, the AudioCubes world, or like in the AudioCubes, area. So, I have some ideas about making the cubes work without a computer, so you don't actually have to have a laptop.
Sure.
Right. So, for example, integration with analog modular synthesizers is something that I want to look closer at, and that I want to do. That makes a lot of sense. So, yeah, I'm thinking about ways to make the cubes work for musicians who don't want to use computers, or they can't use computers, or
right.
It's definitely something I want to do.
Yeah, I think that's actually a really interesting point, because it does seem like the return to hardware is full on. People are starting to say, I look at the computer all day. I don't want to necessarily look at the computer for my creative life as well. But I don't know. I think there's two sides to that story, and also those things ebb and flow. You never know what's going to be important in people's minds at any given time. So I want to thank you so much, Bert, for spending the time talking about this, giving us some insights on how you designed and developed the AudioCubes, and sort of like your vision for the near future. This release is coming out this week, did you say?
Yes, probably end of the week, early next week. The new MIDI Bridge release will be out. We'll be emailing about that in our newsletter, and we'll, put up some videos and that sort of thing.
Okay, and the people who are interested in AudioCubes, where on the web should they go to check it out?
They can go to percussa.com. Percussa is spelled Percussa. And of course, they can also check out our YouTube channel at youtube.com/user/Percussa. If you type in Percussa AudioCubes on YouTube, you can also find a bunch of videos that Mark Mosher and other people did.
That's fantastic. Well, good luck with your work on this and with your continued success with Percussa and the development of the AudioCubes. I think it's really exciting and fun stuff. It's almost alien. It's so different from everybody else's work. But I find it fascinating, wonderful. And so good luck with that. Keep rocking it. All right, man?
Thank you so much, Darwin.
Okay, great. Thanks a lot. I'll talk to you soon. All right. A big thanks to Bert for talking with us about the development and ongoing work on the AudioCubes. I just want to thank all of you as listeners for sticking with the podcast. A lot of exciting things coming up in the next couple of weeks. And other than that, I hope that you have a great week, and I'll talk to you next time. Thanks.